guys. So welcome to Basic Chemistry Plus, and I guess you have seen the previous two videos, and today we are dealing with the third video of the polymer chapter. Now, over here, guys, our target is definitely to complete the chapter in the least amount of time. So you have seen the other two videos as well. We have tried to make it as small as possible, right? The 15 minutes video, and if you just watch that video, that is more than enough for you to understand this. All right. So right now, what we'll be starting with is the condensation polymer. So before I get started, if you have watched the previous videos, you know that whenever I write something, I would be looking at that side of my, like there are another, what do we call it? Like another device is there actually. All right. So anyway, so the first thing that we are going to start with today is the condensation polymers. All right. Now, in the condensation polymer, the first kind of polymer, like all these polymers that today we are going to learn, all of them are super duper important. Because guys, you can see that the things are not really something which is really very easy to, understand, and easy to understand, but easy to recall. What I mean to say is, all right. So the first thing is the name of the polymer is nylon 66. So what is the monomer of nylon 66? That's kind of question that they can ask you. Not only that, in 2019, what they did is they have drawn a molecular structure and they are asking which one is the monomer of nylon 66. So you need to know the structures as well in here. So what is the nylon 66 monomers over here, guys? So let me just zoom in a little bit. First, you look into the name, nylon 66. Whatever number is there, if there is any, like there is something called nylon 6 as well. Okay, nylon 26 as well. So whenever you see this number, always remember these numbers are actually telling you the number of carbon present in here. Number of carbon present in here. So guys, it's a copolymer. Copolymer, do you remember that? Two different types of monomer combined together to make a polymer. This is that one. See, two monomer, hexamethylene diamine and adipic acid. There are two different monomers, right? When you combine them together, we get a combined structure that is getting polymerized here. Okay. So what is this nylon 66 over here, guys? This is our number of carbons. Okay. So hexamethylene diamine would be having 6 carbons. Adipic acid would be having 6 carbons. Okay. Now, when they combine together, we get nylon 66. Now, let me just tell you one simple thing before we get started over here. So there is a acronym goes like OMS GAP, Ohm's gap. This is how we used to remember this. Okay, let me just give some space in here. Ohm's gap. Now, what is this Ohm's gap telling you? Ohm's gap is telling you about the 6 very, very important acids. Okay. O for oxalic acid. M for malic acid. S for succinic acid. G for glutaric acid. A for adipic acid. P for palmitic acid. Okay. You need all these acids one way or another. Okay. So this acronym would help you with that. Now, oxalic acid is something which has 2 carboxylic acids connected with each other. When you go to malic acid, what actually happens is, in between 2 carboxylic acid, there is a CH2. There is 1 carbon present in here. So for succinic acid, what would happen, guys? There are 2 CH2 group in between 2 carboxylic acids. For glutaric acid, what would happen? 3 CH2. For adipic acid, there would be 4 CH2, right? You get the point? And for palmitic acid, there will be 5 CH2. So guys, that is how we remember it. Now, if you just go here, this is adipic acid. So adipic acid means, what would that be? Guys, there would be a COOH and it is OMSGA. 5 CH2 groups, right? I mean 4 CH2 groups, because oxalic acid doesn't really have any CH2 group in there. So 4 CH2 group, right? CH2 whole 4 COOH. So now you can see that in this particular molecule we have total 6 carbon. Like I said, there will be 6 carbon in here. Now hexamethylene diamine, hexamethylene. What is the methylene group, guys? Methylene group is CH2. CH3 is methyl group. CH2 is methylene group. CH is methine group, right? We learned it in class 11. And hexamethylene diamine. So let's write that diamine. So NH2 and hexamethylene. So I have 6CH2 and then now guys, you tell me what would happen. You have learned the aldehyde ketones carboxylic acid chapter. You know what happens when there is a carboxylic acid and when there is an amine. They are reacting together. What happens over here, guys? They take out water, right? So let's do that. So if I write the NH2 in this way, and if I take out water, what would happen? Let's take out this water. So guys, what would I get? I will get a amide moiety. Okay. So how would this look like? So this side also we will be seeing water going out. Okay. And amide instead. So what am I gonna see over here, guys? Then I'm gonna see C double bonded O. I'm writing from here. Okay. Carbon number 1. This is carbon number 1. Then CH2, right? Whole 4. Then C double bonded O. And then what? This water is gone. So I have NH, CH2, whole 6, NH2. Okay. Now this NH2 won't be there. This would also become amide with another moiety. So I would go like this. Okay. So this every carboxylic acid would become now amide. Okay. So this is the basic moiety of my nylon 6,6. So what did I do, guys? I took a what do we call it, like hexamethylene diamine and adipic acid. Then we just take out water from here, and then we get our monomer. So it's a monomer of nylon 6,6. And this, when these monomers are combining together, I'm getting nylon 6. So this is the structure of nylon 6,6 monomer. All right. So this was the thing. And where do we use it, guys? Heat, textile industries, all these things, we use it in there. All right. So this was the thing. Now the next one is nylon 6. So like I told you before, guys, this number, this actually tells you about the number of carbons. You can clearly see here 1, 2, 3, 4, 5, 6. There are 6 carbons in here. That's why it is nylon 6. Okay. The nylon 6 monomer is famously known as caprolactam. Caprolactam is the name of the nylon 6 monomer. Okay. How do we make this caprolactam? That is being taught in JEE. Okay. What we have to do is we have to start from a ketone, then we have to make it an amide, and from there, guys, it would undergo Beckmann rearrangement. You don't need all these things right now anymore if you do not know about it. Okay, this is something like a little bit advanced topic. Okay, so what you need to do is you take E-caprolactam, then what you do is you just hydrolyze it. Now, guys, do you see this is also amide moiety? Oh, by the way, we can call them polyamide, isn't it? Because they have a lot of amide moieties in there. So we can call this nylon 6,6, nylon 6 as polyamides. Okay. Similarly, I'll be teaching you what is polyester. You have heard about polyester, right? I'll be showing you what is. So you do understand, right? There'll be a lot of ester units in there, right? So here, this is amide moiety. Now you tell me, guys, what did we do before? We took an acid and an amine. From there, we took water out to get an amide. This is an amide moiety. This is an amide moiety, right? So if I add water with amide moiety, then what would happen? Then just opposite reaction would happen. Means I would get an acid and an amine, right? So if I add water, what would happen, guys? First, I would break this bond. Okay. Then after breaking the bond, water breaks as H and OH. And then I would give this OH to this section to get the carboxylic acid, H to this segment to get the amine. So what is the final product, guys? What I'm going to get is carbon number 1 would be carboxylic acid now, and then carbon number 2, 3, 4, 5, 6. So that'd be 5 CH2 in there, and then I would get H. Okay, so this is gonna be my nylon 6. Okay, now this is my nylon 6. Okay, so nylon 6 and nylon 6 is clear, guys. What do we use it? See, all the nylons are actually used in different kind of, Kevlars or different kind of, nylon means all the fabrics, ropes, in all those kind of things we need them, right? So nylon ropes, you know about that. So that is where we use them as well. Now, ethylene glycol and terephthalic acid together they make terylene or dichrol. So guys, I told you this pterylene or decron, how do we really make it first? Again, it's a copolymer, right? How do we really make it, guys? So first, ethylene glycol. Glycol means diol, same thing. So ethylene, so I'll be drawing ethylene first. You draw all the structure while watching the video, okay? Otherwise, you won't really get it. And if you draw the structure, you would see that the structures are the only thing that you have to remember. Other than that, the mechanism and everything are very, very simple. Then terephthalic acid. What is terephthalic acid? When we have two carboxylic acid in a benzene ring, which is para to each other, that is called terephthalic acid. So I'd be taking a benzene ring. This is one COOH. This is one COOH. Okay. If the COOH were ortho to each other, then we would have been calling it phthalic acid. Remember Gabriel phthalimide synthesis? There we used it. Terephthalic acid means when they are para to each other. Okay. Now you tell me, guys, what happens? Let's just draw it in this way for you to understand this. What happens when an alcohol and acid reacts together? You know, in presence of concentrated H2SO4, it takes out OH from carboxylic acid. It takes out water, right? If an acid and alcohol react together and take out water from there, then guys, what am I gonna get? I'm gonna get an ester, right? So what is gonna be the product then? The product would be something like OH, CH2, CH2, C, sorry, there is an O, C double bonded O bond, benzene ring, and C double O H, right? This is what we get. So this is, what is this moiety for us? This is an ester moiety. Now guys, this is the monomer. What would be the polymer? So every carboxylic acid would become an ester now. Every alcohol also becoming ester now. Like, so this thing would just keep on repeating to give me the polymer for us. So this is my polymer. Okay. So this is, see, as a lot of esters are combining together, getting repeated together. That's why we call it a polyester. So dicron or pterylene is the polyester. You know that pterylene is a kind of, you have heard about terracotta. Terracotta is a kind of pterylene and cotton together. That kind of fabrics are called known as terracotta. So you can see that in safety helmet we use it, in cotton and wool fibers we combining together and we use it. Okay. So this is also a kind of fabric, pterylene. Alright. So guys, this was about the pterylene, and which is ethylene glycol and terephthalic acid. Together we get it. Now the next one is glyptal. Glyptal. Okay. What is glyptal? So the video is becoming a little bit today, right? So anyways, it would be a 20 minutes video if I can see the timing right now. It's like 13 minutes or 14 minutes are going on right now. So guys, it will be a 20 minutes video, but we'll be completing this topic today in this video. So ethylene glycol and phthalic acid gives you glyptal. So again, ethylene glycol is something that we know, which is our CH2, CH2, OH, OH. Then phthalic acid. What did I tell you? What is phthalic acid? Terephthalic acid is when they are in the para position, and phthalic acid is when they are in the ortho position. So I'd be drawing the benzene ring in this way, and then I'd be keeping both the carboxylic acid beside each other, like this. Alright. Now what would I be doing, guys? I'd be just making them ester, just like before. So what would I do? I would take out hydrogen from here, OH from here, and would make an ester. So guys, try it with me. How would the ester look like? So first I would go like the C double bonded O. Now it has become an ester with ethylene glycol. So this is the thing. What did I do, guys? I have written them together and I have taken out the water from here. Okay. And here also C double bonded O, bond O, CH2, CH2, like this. Now this is my monomer. What would be my polymer? So to draw the polymer, you don't write the hydrogens because they are just keep on making esters from both the ends, right? So just look like this, and then see, this is no one is ever going to ask you how to draw the polymer. You just need to recognize it looking at the 4 options. Make sure you can do that. So this is phthalic acid. So that's why it is glyptal. Whenever it is terephthalic acid, it would become our polyester, which is terylene. This is also a polyester, right? Glyptal is also a polyester. So terylene and glyptal. Okay, glyptal is being used in paints. All right, now three more are left to go, guys. First is the bakelite or novolac. It's not or, it's supposed to be and. Bakelite and novolac. Okay, now what are they? This is also, we are just talking about copolymers right now. Okay, so first we take phenol. So phenol, I guess, guys, we know how does it look like. It look like this. Then we add it with formaldehyde. Formaldehyde is HCH, right? Now what would happen if I react a phenol? Let's just for my convenience, I'll be drawing like this. If I react a phenol with formaldehyde, then what are supposed to happen? What are supposed to be my products? So see, this lone pair would come over here. This electron would go and attack on the carbon, and this bond would break, right? So we have done this kind of nucleophilic addition in aldehyde ketone carboxylic acid. So what would happen, guys? I would get two products. One is CH2. This would break first, O minus, and then it would take the hydrogen from water and it would become CH2OH. Okay, so CH2OH on the ortho and CH2OH on the para. These are the total two products that we can get, right? Where para is definitely supposed to be, guys, our major product. If you take ortho, then you get bakelite. Okay, just one second. Ortho gives you novolac. Okay, ortho gives you novolac. Para gives you ortho. Okay, I'm gonna show you right now. Bakelite is a little complicated. Novolac is easy. So guys, novolac is a linear polymer. Remember, linear polymer when they are just adding up in a line. And bakelite, it is known as what do we call as cross-linked polymer. This is a cross-linked polymer. Okay, now linear polymer means they are just gonna get added up. So this OH, this CH2 getting added up with another bakelite unit, another, I mean CH2OH unit, OH, then CH2, then again it goes like this. So what is actually happening, guys? How did I make it? I first draw a OH, CH2, OH. Then I reacted with another OH, CH2, OH. Then I combine these two segments together. Okay, this is how the combination is going. Okay, so in the ortho way. So if that happens, this is the linear polymer. You can clearly see that. Okay, this is my novolac. This is my novolac. All right. Now, what is bakelite? Bakelite is, I need some space for that. So first, guys, we have to understand, to make bakelite, what you have to do is, you have to take the phenol and you have to treat it with excess amount of formaldehyde first. Excess amount of formaldehyde. If you treat it with excess amount of formaldehyde, then what would I get? I think the picture is visible. Let me just see once. It is visible, right, guys? So what would I do? I would take OH and I would react it with excess CHO. So as a result, I would get a CH2OH in here and I would also get a CH2OH in here. This is what you need to begin with. Now what you have to do is, you have to combine them, link them. So how would I do that? See, one kind of linking would happen just the way bakelite, I mean novolac got formed at that time. Just the way novolac got formed there. Okay, I'm not drawing anymore. It just goes like that. There is a CH2H on the bottom side as well. That would also combine with another ring like this. So I'll be drawing what? The CH2OHs over here. Let's draw all the things with me, otherwise you won't be able to remember. Now I'll be drawing this ring one more time in the bottom, but in the upside down manner. So it means I'll keep the OH in here, then CH2, here. I think I need to shift it a little right. Just one second. I have to shift it because when the polymerization is going on at that time, what's wrong with this? A little to the right. This would be okay. Now just keep on adding them up like this, then CH2, then this OH. Okay. Now there is another CH2H we have in the bottom. So from there you need to connect them together. So that means if I do not draw the OH over here, I'm just combining them. You just need to combine them like this, in this way. Right? This is cross-linking polymer. This is bakelite polymer. There is something I think I need to change over here while I taught you the first one. When I give excess OH, I mistook it over here. I get ortho and para product separately, right? Because I need both of them actually to make this happen. You can see that, right? I need the ortho product as well as the para product. Okay. So this segment, the top segment is actually what I'm making with the para product. You can see that. This is the para product that I'm using. And the bottom segment that I'm using, this one is the ortho product segment. Okay. So this is, guys, what bakelite is. Okay. Now, one last, melamine formaldehyde for us. So guys, melamines, this structure was asked in 2017 JEE. What is melamine structure? You draw benzene ring. You draw benzene ring, but in the alternating position you put a nitrogen. Draw benzene ring, but in the alternating position you put a nitrogen. Otherwise, wherever you have added carbon, wherever you can see carbon, you add an NH2 from them, that side. Okay. And like the benzene ring, you give double bonds to them. This goes your melamine molecule. Okay. So melamine, when it is reacting with formaldehyde, guys, how would that look like? How would the reaction go? For this lone pair of amine would go and attack this carbon, and this bond would open up. After the bond opens up, it would become OH, it would take hydrogen and it would become OH. So NHCH2OH is the bond. So although you might see that the video is a little large, long, going on a little long, but the entire time is taking because I'm writing everything in here, right? Otherwise, the topic is not really that big that we have learned so far. No H. Okay. So guys, from here, you just added NHCH2, and this polymer is going to happen. It's going to get polymerized. So this is our melamine formaldehyde. So this is actually an unbreakable crockery. So crockery, you have seen that. So to make the unbreakable crockeries, we need melamine formaldehyde over here. Okay, you can just fast forward to all these things, guys. Or I forgot to tell you about the urea formaldehyde as well. I hope I'll be making one more short video of 5 minutes to just complete it. So urea formaldehyde, guys, there, as the name suggests, you take urea and you take formaldehyde, HCHO. So when urea and formaldehyde mix together, again, guys, this is the attack would happen, and then NH CH2OH, the same thing. NH2, C double bonded O, NH, CH2, O polymerized. On the right hand side as well, that can happen. So NH, CH2 polymerized. Okay, this is urea formalin. So this is also unbreakable crockery or unbreakable crumbs. We make it from there. So guys, the clock is ticking at 25 minutes. So I'd be making a separate video where I'd be putting the list of the things, because I'm going a little bit detailed in there. You can just fast forward these videos because I'm taking much more time to write the things. Okay, so that would be it, guys. See you then in the next videos, which will be coming up within 1 or 2 hours. And definitely, guys, you'll be getting the link to the previous videos and the next videos in the description only. Okay, so bye everyone.